Transparency.dev Summit. Did you all have a good day one yesterday? Yes. It was good to see lots of folks at the darts. Anyone here who tried out the darts? Great. Was that good? Anyone do it for the first time? Oh, that's awesome. Great. Well, we've got another great agenda for you all today. We're going to start off with talks in the morning, and then in the afternoon get into the fun stuff of breakout rooms. We'll share more details at lunch about the breakout rooms. Also, I'll just quickly shout out, thanks to all those folks who have signed up for lightning talks on Friday. There is still time. I think we've got 5 or 6 folks so far, but send me an email, a Slack message, or just come find me if you're interested in doing one, and I can share a lot more details. Okay, looks like everyone's had a chance to grab coffee and get a seat. So this morning, we are going to focus on CT. Which is, we've got some amazing speakers I'm looking forward to hearing. So without any further ado, I would love to introduce you to Joe and Philippe, who will be talking about lessons learned from CT. Please give them a round of applause.
Is it on? Hello? Yes, it's on. Hello, I hope you're all ready for day 2, and let's get started. So today with Joe, we're going to talk about scaling transparency ecosystems, specifically how to go from nothing or just one log to what CT is today. So my name is Philippe. I'm in the Transfabric team where I'm the tech lead of certificate transparency. And before that, I was an SRE looking after traffic. I'll pass the mic to Joe.
Hello, and I'm Joe. I manage a small team on Chrome's security team that focuses on network security and associated stuff, which includes Chrome's CT program. Let's see. All right. So this lovely image came up yesterday, and I had to frantically add it to the slides. I think there's a perception that now that CT is deployed, the space is pretty well solved, and that CT is relatively static, and that there's little additional work to be done, and maybe there's not a lot to be learned because now we're on to shinier and newer things. I obviously don't think that's true. As CT has grown to be sort of a critical part of the web's infrastructure, spanning billions of clients and hundreds of certificate authorities, and a whole diverse set of log operators, we've had to solve a bunch of big problems that the original designers didn't really think through or envision at the time, or at least didn't have the cycles to envision because they were busy designing the core of CT itself. Many of these problems aren't about signatures or Merkle trees or the sort of fun stuff that we spend a lot of time in this room talking about, but they end up being no less important to the success of the system. So I guess the real thesis of this talk is, as you think about designing your own transparency systems or building up those sorts of those ecosystems, to not forget about those sorts of problems too. So we also have problems in CT that aren't super well solved, and I want to hint at least a little bit at those because I can't let an opportunity pass me by without saying that, like, hey, cool stuff happens in CT too, and you shouldn't forget about CT. So so Philippe gave a talk yesterday that used this slide that highlighted the importance of having an end-to-end story for your ecosystem, and this is an attempt to show you what some of the steps of drawing the owl have looked like for us.
So why CT? Why do we take CT as an example? CT has been out there for quite some time now. I know a lot of people have been working on it since its early days. And if we look at the timeline, a lot of things have happened over this last few years. There were a lot of key moments that really defined CT and that shaped it. So obviously it started in 2011, and then 2013, the RFC was out, and the first public log was out as well, pilot. And then very quickly, all the ecosystem kickstarted and new things starting to spawn up. So there were more logs. In 2015, Chrome started to require SCT for some certificates. Cert.sh was launched as well, still up, thank you. Very quickly, we had to shard the logs. Apple joined the crew. Chrome made it even more required. A few years ago, SCT auditing was launched to close a loop that is indeed very important to close. And a big moment was in 2022 when the one Google log policy was removed, which means that certificates had to be logged, but in any log. They didn't have to be in a Google log. And things keep happening. 2023, a bit flip. Yeah, these things happen, they're rare, but they can happen. And a big moment as well for certificate transparency, static CT API, hopefully a new feature for CT. So as we can see, a lot of things happened. And we are very far away from where we were back in the days where there was only one log. But let's roll back a bit and think of that time where we only had one log. And the first question that we can ask is, well, what happened if the log fails? Bit flips are a thing. That bit flip could have happened in the early days. Well, it's not great. But what would be even better is if we had maybe multiple logs and then nothing would happen. A log fails, it's okay. The ecosystem keeps moving forward and nothing too bad is happening. So very quickly it became clear that you need to have multiple logs. And it turns out that going from one log to multiple logs is not necessarily that straightforward. So we talked about bit flips, but there are multiple reasons why you will want multiple logs. And you really have to think about all of them to decide how you want to shape all these multiple logs and how you all want them to work together. So why logs would fail? There could be many reasons. Integrity, so with bit flips, but it could also be that there's an entry, you said you would include the entry in the log, and it turns out you actually never include the entry in the log. That's a problem, because the log should really include all the entries. Could be an availability problem. It could either be you cannot write to your log anymore, or you cannot read from your log anymore, which are actually two very different properties that won't have the same impact on the ecosystem. Scalability could also be an issue. Logs grow very fast. Make sure you don't run out of disk. That can happen. That has happened. It is hard. Capacity planning for City is hard. You run a service that is publicly writable on the internet. Of course, there are a lot of checks, but this is hard. And then last but not the least, compromise. You could end up having some data in your log that you don't really want to have because, yes, this is a service where everybody can submit a certificate. You could have a split view because system fails sometimes, or it could be an attack. Hopefully, that will never happen. I was saying that logs grow fast, and yes, they do grow extremely fast. That's the number of certificates expiring every year. So be careful interpreting that. It doesn't mean that this is the number of certificates in every CT log, because we have multiple CT logs, and also pre-certificates make all of that a bit harder. But we can see that it's growing fast. We're about 4 billion certificates in 2024, and that keeps growing. We need to take that into consideration when you have multiple logs. How do you make sure that you're going to be able to sustain all that traffic? Okay, so we need multiple logs. It's growing very fast, so a good idea would be to shard the logs per year, which means that at the end of every year, you can say, okay, now we can remove this log is okay, which is a good thing to make sure that you don't keep data forever and that you can actually have enough disk. But how do you manage all of that? Because there's just okay, there's a lot of logs. You need to configure all your clients to trust these logs. The easy answer is just push a log list to your binary, right? You have your binary checks for SCTs, relies on CT, just push a log list over there. But wait a minute, how often do you update your binary? Because what happens if you bring a new log up, but you have not updated your binary yet, and then the client doesn't know about this new log, it just doesn't work. And then, okay, even if you update your binary frequently enough, what is if there's an emergency and you really need to push something now because something new has come up or a lot has gone down? What happens if your device never gets updated ever? It quickly became clear that actually, yes, you need to have a log list because you need to push this log list dynamically to make sure that you can update the list of logs without having to push your binary. Seems easy. It's okay, just push a log list to all your clients. But it turns out that log list needs to be signed, right? Because, well, you don't want to trust any log list. Okay, so now you need to add key management. And also we say, okay, logs come up, come down. When should you start trusting a log? When should you stop trusting a log? You need some time stamping. You need to say, okay, you need to start now. You need to have some state as well. So how do you say, okay, this log is ready, this one is not ready yet, this one you have to stop using? And that starts to be a lot of things that you have to manage. And keep in mind that now we have your binary and you have a push mechanism with a log list. What happens if you come up with a new standard for logs, like static CT API, and that means that maybe you have to change your schema of the log list? Oh, now you have to update your binary and your log list at the same time. So you have to version your log list, and you have to keep everything in sync. And here you are with yet another massive layer of complexity just to run multiple logs.
Okay, so you've figured out how to update your log list with a bunch of logs, but all the logs are still run by you, the service provider. Well, what happens if your entire company is compromised and all of your logs are compromised all at once? Well, obviously that's a bad situation to be in, so we have to introduce additional complexity to handle multiple independent entities. And actually, that's where a lot of the pain points in CT come from, is just the more entities that we introduce, the more juggling there is to do. So we have to have multiple operators. As soon as you have multiple operators, though, or like strangers, logs that you don't inherently trust, you end up in a world where you have to decide, well, how do I decide which logs to trust at all? This is critical infrastructure. Just is anyone who raises their hand, you just say, sure, come on board. Even though CT is designed to be robust for failures, you'll see that there are not so many CT logs and CT log operators that you can just accept the rando off the street. You have to have some high confidence in them. So we spend a lot of energy in Chrome monitoring logs to ensure compliance. Chrome has dedicated infrastructure that constantly monitors logs to verify that they're holding up their end of the bargain. Part of that is ensuring that logs are like matching the specification and like are actually RFC 6962 logs if they're supposed to be, and to, insofar as we can, make sure that the append-only properties are maintained. We can't verify that we're not seeing a split view, so we can't protect against anything, or everything, excuse me, but we can protect against a lot of stuff, and in particular, the biggest pain point that we're actually monitoring for is availability. It's that we are about to add this log as critical infrastructure to the web, where CAs and other cert submitters are going to be relying on it in a critical way. And if your log is like 25% available, that's not really going to cut it. So a lot of the monitoring is just making sure that the log is there when it says it's going to be there. That is a huge pain point for CT. Chrome only requires 2 nines of availability, which for those in sort of the SRE space, that's not a very high bar, and yet it is regularly the case that we have logs that drop below that threshold, despite the fact that our log operators are all very capable and doing the best they can. So when a new log applies for inclusion in Chrome, we monitor them for several weeks to ensure that, actually, let's start making the animations work a little bit for us. So this is the graphic we saw before. We have this additional compliance monitoring infrastructure. When logs apply for inclusion in Chrome, we watch them for several weeks to make sure that they seem to be okay. And then after a certain point, we say, okay, we're going to trust this log. And so we start to push them out to the client, but even once we've decided that they're trustworthy, that doesn't mean they're necessarily safe to use. And so we end up having to introduce this huge, complex state machine that sort of captures what we think about a given log at any given time. So pending is like what happens when we're first evaluating you. And then you get to qualified, which means we think we trust you, but it's not actually safe to use in Chrome yet because not all Chrome clients will know about you yet. And then you have these retired and rejected states, which are like the exit path, if you will. Like by the time we're rejected, you can totally turn the log off. So these things get quite complicated, even though all we're talking about here is like shipping logs to clients, right? There's nothing super shiny here. So Chrome maintains the policy for what you need to present in TLS handshake or at TLS connection time to connect in Chrome, and to use a public TLS certificate in Chrome, you have to present a set of SCTs that satisfy our policy. That policy requires that you present SCTs from at least 2 different log operators. Why 2? Well, that gives us some protection against one of those operators bursting into flames. Why not more than 2? That would be great, but we have a total of 6 operators, and we don't want every single operator to be sort of on the critical path for issuance on the modern web. And so there's a trade-off here. Ideally, you'd have, you'd require more SCTs, but that puts more people in a critical position and also increases the size of the handshake. We also require that one of the SCTs comes from a log that's still trusted when a certificate is used by the client. So not just at the time that it's issued or you went and got the SCT, but like when Chrome checks. We would love to be able to require more than one, but in this case, we would lose our redundancy properties here, because if a single log fell over, then suddenly we'd break every website that relied on that SCT. And so we need to permit for some breakage, but we can't permit complete breakage. We can't say, well, the logs were trusted at the time that you got the SCTs, because if we removed trust in a log, what we're saying is we don't believe that they were always doing the right thing. And so if none of the logs are trustworthy, then that certificate could be entirely invisible on the web. Point being, you get these awkward trade-offs where you're like, well, I need some redundancy here, but I also don't want to break the web. And there's no magic bullet here, but you have to be quite thoughtful about these choices, which can get arbitrarily complicated.
So it's great that we take all these measures to make sure that it's fine, log can fail, but it still means that running a log can be hard. Of course, we can sustain some outages, but everybody would like to avoid an outage of the log. Running a log it's a big responsibility. You know that you're going to be in the issuance path, so of course you don't want to fail. You want to make sure that people can keep getting new certificates. You're going to run independently, publicly writable, publicly visible. You're going to put your signature on it. Yeah, you have to be serious about it, and it's a commitment. And also, it's a commitment in terms of system resources, but also humans. Logs need to have certain availability. It comes with an on-call rotation, so you need to back it up. But it's also good. It's a business opportunity. We say that it was on the issuance path. So if you care about issuing certificates, you should really care about having logs that are actually running. It's a critical service for the internet. I know Alvin likes to say that as well, that a lot of things have to run for the internet. DNS here, it's a system we need to have. Well, certificate transparency is the same thing. We need to have it if we want to have a safe internet. And the good thing is that despite the fact that it's hard, we are taking steps to make it easier. And I really want to thank everybody in the room, in the live stream, or people who have not joined us today, but who have worked on CT over the last few years, for all the conversations and also all the massive effort these last few years with static CT APIs, Sunlight, Tessera, all of this. So I think this is good. Let's keep the momentum and let's keep making things better.
Part of the purpose of the previous slide is to highlight that operating a CT log is hard. And so it is in that context that I want to take a moment to acknowledge the log operators that have invested in CT over the years. It is critical infrastructure. We are quite grateful for you. Even though like part of my job representing a CT enforcing user agent is to sort of be hard on operators at some points, because I want to keep the standards up. But the internet would not be as secure without these organizations on the page. So if you want to join these fine organizations, come and talk to us, and we'd love to help you make that happen. All right, let's talk a little bit about verification and some of the other weak points of CT. So first off, CT doesn't do squat if you don't actually look for misissuance. Since any website can get a certificate from any CA at any time, there's no way for browser clients to identify misissuance themselves, obviously. That means that individual sites need to be watching for their own misissuance, and that has terrible scaling properties. There are billions of sites on the web, and all of them have to individually opt in to get the full value for CT for them. CT is not safe by default. Which I think in safe by default is much more of a buzzword now than it was then. But that's a property I wish we could somehow add. There's no way to add that, but that's a reality here. That's particularly terrible in this case because site owners' lives are already really complicated. If you're a site owner and you're trying to do the safe and secure thing, there are a million things you have to juggle. If you're a developer, you're already like, I have to deal with CSP and my head hurts and I don't understand how any of this works. And now the network security people are talking about certificate transparency and I just don't care. Can we make this simpler? There is no universal answer that we have for them for how should I be checking for misissuance? How should I keep myself safe? What's the free and straightforward way to do this? And that's a bad property for CT. So in practice, CT ends up being extremely useful because it gives us this holistic view of the web. And I don't want to minimize that value at all. But in terms of the original promise of CT, which was to address the DigiNotar hack that Al talked about yesterday a little bit, in practice, CT ends up being a lot of infrastructure to privilege a relative few, because you need to be a Google or a Cloudflare or one of these big organizations in practice to be tracking it yourself, and relatively few smaller organizations are opting in for stronger protections. So as you design your own transparency systems, I encourage you to have a really good answer to ensure that you don't build all of this incredible transparency infrastructure that then no one actually uses. Right? That's not a successful story. Probably in your ecosystem, you won't have the awesome side effects that CT has had for your ecosystem, because the web is massive in a way that perhaps a smaller use case might not be.
So let's say that, okay, you have the resources, you do the right thing, you actually monitor everything. It's not necessarily straightforward to actually detect what happens and whether something is good or bad. Even if you're a big organization, you have all the resources, you'll have a lot of domain. It's difficult to route your alerts. It's difficult to know, actually, is it a false positive? Is it really a bad certificate that has been issued? You don't really know. And even if you find something, you find the right person, something that should be acted on, people might just ignore it because they're like, well, yeah, sure, fine, it's okay. And that could very easily be a headache. Now, if you're a small organization, you would have different problems. Like maybe you just don't really know how CT works because, well, you don't have the resources for that. You don't really know how to investigate. You don't really know what to do, what to report if you find a bad certificate. And it's a big question in CT. Like what happens once you find a bad certificate that should not have been issued? Depending on, you need to investigate to see why it was misissued, and then you can see what you can do. And it is very critical that you know exactly what you're going to do once you detect something. That shouldn't be there for CT, but also when you design your own transparent system, really think about this verification step. How are you going to do it? How are you going to act on it? Because just putting things in the log is not enough. Verification is very important. If there is one takeaway to take from this talk is if you build a system, please think about verification. And you want to make sure that verification is as easy as you can to do. One thing that makes CT very hard to operate and very hard to navigate and very hard to make sure everything is okay are SCTs. So the second takeaway is do not do SCTs. If you can avoid them, just avoid them. It's very hard to think of a scenario where you really, really need to have SCTs. For historical reasons, we needed to have them for CT, but please avoid. Don't do it. Oh, yeah, I do have a next slide. So as you've seen, okay, it's cool, you want to have transparency, you want to have one log, but oh no, you need to have multiple logs, or you need to have multiple operators, you need to have a log list, and oh, you need to do verification, and you need to manage all these things, and it is hard. But what underpins all of that is that now you need to coordinate all of this, and there's a big overhead. So this is what CT looks like today. We have a lot of ecosystems participants. Domain owners, CAs, user agents, log operators, log monitors, log verifiers, and every single of these has multiple instances. You will see that some organizations as well have multiple hats. And so you have to navigate that, you have to make sure that everybody moves in the same direction and can agree on a path forward. There are many, many domain owners. I don't know how many. I'm sure we couldn't find out somehow. But yeah, they should all care about CT. There are plenty CAs. I've put a few names here, but there are way, way more than that. User agents, there are a lot. There are a few today that enforce CT. Hopefully there will be more soon. But yeah, you have to make sure that they all agree, that you keep them in sync, that they don't diverge, because eventually we all care about one single HTTPS TLS ecosystem. Log operators. Today we have 6. That looks good, and yes, this is good. Is this enough? Probably not. We need to have more. We need to make sure that logs don't go down, that operators don't go out of business, that also we have enough SCTs. Right now we require 2. Maybe we should require more, but for that maybe we need more log operators. So really think about how many log operators you will need and make sure that it's a sustainable path. Monitors, they are very important. There are a lot out there. I'm sure I forgot a lot of them as well. But as we said, monitoring is very important. It's still a bit of an unsolved problem in CT. How do you make sure that you catch all the things that you should be catching? Because monitors today are not very verifiable. But the good thing is that with static CT APIs, reading from a log should be easier. So now you can read directly from the log and monitor your own things. But there's a lot, clearly more than 12 today. And verifiers who really look at whether the log is operating correctly in terms of like hashes and that the logs are consistent. I'm sure I forgot some as well. But yeah, that's a lot of people around the table. And you all want to make sure that they all move in the same direction.
I want to dig into just a few of these stakeholders very briefly. As Philippe has said, the CT ecosystem has a bunch of different entities, but we're one big internet. So we have to stay sort of compatible and sort of walk in lockstep. I represent Chrome, but Chrome and Apple both publish CT policies. If you look at them, they look totally different, but the contents of them is almost exactly the same. That is not an accident. But there's no cabal in the back that's coordinating that. What that is folks in both organizations trying to make sure that if you have a certificate on the web and you want to attach SCTs to it, that it will continue to work everywhere. That's a really important property that we think holistically as the system. But that also means sometimes you end up compromising or shifting your approach because there is no central authority here, and there are different people with different priorities. It's not just enforcing across user agents, though. One of the other challenges of the CT ecosystem is that we have all these cert submitters and other actors who, in theory, should be consuming that big public log list that we were talking about earlier, but they aren't. It's hundreds of discrete organizations, and they're just filled with people. So you spend a lot of time in CT just talking to a mailing list and trying to say hey, this is important to make sure that you see, that this change is happening. So yeah, you spend a lot of time doing announcements. And alongside that, you also try to spend a lot of time encouraging a healthy community with open communication channels. We try to encourage events like this, where people can come together and actually talk about these issues. CT does not work unless there are engaged folks from a lot of different organizations coming together to try to make it better and stronger. And when we make mistakes, we all try to learn together and that sort of stuff. So all of this is slow, right? It's part of the WebPKI. The WebPKI is notoriously slow. And when we make changes in CT, it can be disruptive to a lot of different participants. Obviously, they impact browser users and hundreds of CAs, et cetera, et cetera. So when we make changes to the ecosystem today, we need to be, they either need to be fairly inexpensive or they need to be overwhelmingly important and well justified. You'll note that all of the current CT logs are RFC 6962 compliant, not RFC 9162 compliant, even though 9162 is frankly objectively better than CTV1. Why is that? It's because implementing it would have been very expensive, and we didn't think the juice was worth the squeeze. Right? That would have been quite a big lift for relatively limited benefit. Currently, we're undergoing this transition to the tile logs, to static CT API logs. that's the biggest change CT has made in years, for sure. And there's momentum there because it can potentially dramatically reduce the costs for log operators. And that can mean more log operators, which means a healthier ecosystem. So that's where we were like, oh, yes, this value is really important. And even so, that API has very modest changes from the perspective of many members of the ecosystem, right? The submission path for cert submitters doesn't change at all. And that's a really important property that helps ensure its success. There's still lots of work to do in CT. We're working to reduce merge delays, which sort of moves us towards a world that is less bound by the mistakes of SCTs. And there's other work in completing the loop and improving revocation support across browsers, which gives a partial answer to the story of what do you do if you actually detect misissuance. So there's lots of active work here. I think when we first started sketching out the OWL, there were a lot of steps that were underspecified and unexpected. And I think if we're honest with ourselves, the owl we drew is not necessarily the owl we expected to draw, but it's actually a pretty cool owl. So I guess if there's, again, one core lesson for other transparency systems, it's not to underestimate the challenges that'll come along the way as you grow, and that a lot of those challenges aren't, again, in signature schemes and data structures and other cool stuff like that, but that there are worthwhile problems in this space, notwithstanding, even if they're in areas that you don't necessarily expect. And that's all we got. Thank you.
Do we have any questions?
Hi. So in one of your slides, you said it's a business opportunity. Could you elaborate on that? I have some thoughts myself, but yeah, what is your perspective?
If you issue certificates, you need to have a log. Because today, like CT is in the issuance path. So if you really care about having certificates that are usable, you would like to run the log, yes. Especially for your own certificates. And I know some CAs run logs and submit their own certificates to their own log, which are accepted by Chrome and Apple and all the other ones.
Obviously, from my perspective, wearing my Chrome hat, like there are lots of good CAs who don't run their own logs, and it's okay. That's why we have the lovely CT operators that we do. I would say that if you're a organization that wants to get your name in lights, along with the other fine folks that we had earlier, Sectigo and DigiCert and TrustAsia and Google and Let's Encrypt and I forget somebody, I can't count to 6. And Cloudflare, I'm sorry, there's the 6th. This is a good opportunity for that. So then maybe that's a business opportunity. But I see it as a service towards a better internet. And yeah.
Thanks for the excellent presentation. I have a question regarding, you did touched briefly about if the log is compromised. So have you suggested any kind of strategies if that kind of situation happens, and what would you recommend from your experience if at all you have anything like that?
So from Chrome's perspective, we would treat a log compromise like any other type of log failure. There's enough redundancy in the system that as long as there's only one log that's compromised, that's okay. In a transparency system, our goal is visibility into the certs that are out there, and another functioning log is enough to maintain that property. You do operate in a world where if you don't trust that log anymore, now you have a reduced, like you're down to one log for this impacted certificates. And our response to that is we have a relatively complicated rollout process that tries to ensure that we minimize the impact on future certificates. But there's always losing one log is basically always free and painless. As soon as we lose a second log, we're in a much more interesting situation, and there's no magic answer there. You have to balance, whether you're willing to break those connections to maintain the security of transparency property, or whether you think it's more important that those connections work. And, thankfully we haven't found ourselves in that situation, so we haven't had to make that call.
Can we just get Matthew to set up while we take a couple more questions?
Hi, thanks for the talk. About the user agent number, I was quite shocked to see only 2+. I think Chrome and Apple ecosystem. What about the Microsoft one, Android one, Firefox one?
So, you know, we are none of those other organizations. I am Chrome. You know, Philippe is Trust Asia, or Trust Asia. It's Trust Fabric. Congratulations on your new job. So Apple and Chrome right now are the only two that publish a policy and have their own inclusion processes and that sort of thing. Microsoft does have a sort of, I jokingly call it like a shadow CT program because they do enforce CT. Edge enforces CT actually with a slightly different policy than I think Microsoft, the platform, like the Windows platform does, but Brave also enforces CT. There are lots of other organizations that enforce CT, and by and large, they follow relatively closely one of the Apple or Chrome programs so that they don't have to sort of take on that administrative burden themselves. I'm quite excited that there are lots of rumors floating around that there are additional organizations that will be enforcing CT soon, and so I'm excited to hear that. And I know in particular that I think we're on the record saying that Android is working on platform support. So
I don't have that much clue about CT, but I understood correctly that on the browser side, you only see the CTs, so the use is very dependent on how you do this SCT auditing.
It depends on what, I mean, so SCT auditing is a tool of evaluating trust in a given log. If you assume that at least one of your logs are faithful, then SCT auditing is an important check, but it does not impact the core offering of CT, which is to offer certificate transparency, like as in availability of that information. You'd have to have multiple logs that did not include a certificate for it to impact that property. So Chrome does do SCT auditing, and it is primarily aimed at detecting, misbehaving logs. It's not about ensuring that a given certificate is included or is visible universally somewhere in the CT ecosystem, if that distinction makes sense.
Yeah, and just a reminder, we do have the CT breakout room this afternoon, and Bill and Joe will be there to dig into things. So we'll do one final question before going on to Matthew's.
Related question to that. So now that you have some SCT auditing in Chrome, my question is, do you consider the SCT auditing loop closed now, or if it's not closed, then what do you think is missing? If you have any guidance for people that are looking into this problem.
It was closed enough for us to feel comfortable removing the one Google log requirement, which, to be clear, was a Chrome requirement that we weren't comfortable with the ecosystem until we had some level of auditing. But the current SCT auditing mechanism is a relatively small sample, and so there's quite a bit more to do there. And I think actually an important takeaway from Lena's presentation yesterday was there are, in particular, some exciting PIR developments that have possibly come along since we built SCT auditing that could enable a much higher frequency of auditing than we have right now.
So the way I look at this is that if we have a good SCT auditing mechanism, then we can actually decrease number of SCTs, because that's just a proactive check, right, in order to, how hard is it to get a certificate out there that the browser will accept, and then SCT auditing is, how confident are we that we would detect if they're doing something bad. So maybe this would also make it easier to have a healthy ecosystem if we also have a healthier SCT auditing.
Yeah, one thing I'd say about CT is that I at least am laser focused on things that are pragmatic improvements that we can make. And I think that at the moment we have a system where, 2 SCTs gives us quite a bit of safety. And so the bar that you'd have to get to for SCT auditing is quite high to achieve the same level of comfort that we have with the ecosystem. So yeah, I think that's possible. quite frankly, Chrome's not going to investigate that space because I think we have what we need, but there's definitely more to do there.
Great. Yeah, I'm sure we could have endless discussions, but I'm going to call it there.
Yes,
And yeah, see you in the CT breakout room to pick up the discussion. But yeah, that was an amazing talk. Let's give a round of applause to Chervine.
And now a talk from one of our star log operators. They're all star log operators, but he is a star log operator.
All right, thank you. So my name is Matthew McPherrin. I work at Let's Encrypt as the tech lead of the SRE team, who both runs our CT logs as well as runs the CA, which submits to the CT logs. So I probably don't need to introduce Let's Encrypt too much in this audience, but we're a free, automated, and open certificate authority brought to you by the nonprofit Internet Security Research Group. Our goal is to encrypt the web. We offer free certificates via the Open Acme protocol, which allows many different software products to build certificate issuance into it, allowing easy and automated certs everywhere. And I think we're succeeding at that goal. We issue millions of certificates every day and are continuing to grow with a curve that is slightly worrying to me as I plan our capacity. But I'm not here to talk about the CA today, while Let's Encrypt is a major CT client submitting lots and lots of certificates. We are also a log operator, as Joe mentioned, and that's what I'm here to talk about today. Because we've talked a lot about running a log in very vague terms, but apparently this is the meme image of the day. We'll talk a little bit about drawing the rest of the owl. So we have one trusted log right now, which is named Oak. It launched in 2019, running Trillion, which is the most popular CT log implementation today. Or at least many of the log operators are running it. We run it in a Kubernetes cluster with storage in MariaDB on AWS. There's about 4.5 billion certificates in it. The patch to Chrome marking it as qualified was 5 years ago on Tuesday, so that's very exciting. I think there's probably some familiar names in this CL. But it's not just one, 4.5 billion certificate log. So we have temporal sharding based on initially years, but starting this year in 2024, we started to get concerned about the size of individual shards. So we're now going to half-year shards. So the current 6 shards we have active, which is 2024 through 2026, are half-year. And the biggest of those shards currently has about 1.2 billion entries in it. The architecture diagram here is a little complicated. We currently have about 100 pods running on a Kubernetes cluster on this sort of big microservice-y thing. It's possible to fit the whole architecture on a slide, which is, not a lot of systems can do that necessarily, but there is sort of a lot of resources going on here. Roughly, it is 7 Kubernetes workers, which are these C7A 2x large Amazon VMs, which is like 8 CPUs, 16 gigs of RAM. The big databases, which we have per shard right now. I mentioned, temporal sharding. Actually, initially we ran multi-tenant the first couple shards in a single MariaDB, but then we started hitting into size limits on what we could fit in 1 DB. So then we started running multiple DBs, and then we hit those size limits again, and now we're running these half-year shards, which are even smaller. And then probably the biggest resource for us is the bandwidth. We're doing about 10 terabytes a day. It's very spiky, but that sort of works out to be about a gigabit per second continuous read traffic out of it. And that's where a lot of these pieces of infrastructure need. We do have one non-standard component that is not part of Trillion, which, because of the read traffic we had, we just really couldn't sustain it coming straight out of the MariaDB instances. So we used to actually have much larger, much more expensive DB instances than we do today. And we were still having scale trouble. I think Joe sent us some angry emails about our log uptime. We could have probably started rate limiting harder, but we didn't really want to do that because the whole point of CT is to get that data out to everyone. So we wanted to focus on that read scalability. So we wrote our own S3-backed read cache in front of Trillion, which serves the bulk of our read traffic today and has sort of better horizontal scalability than our previous reads coming straight out of Trillion. So I did mention, we've had some scalability problems. A lot of that has been related to DB overload. We've had other issues. We had one test log that actually died. Our test log was called test flume, which contained sort of the sole Let's Encrypt production traffic as well as our staging. So it was just a bit bigger because of that extra staging. So it hit a 16 terabyte size limit in MariaDB on RDS table size limit, which was fortunate that we hit it in test flume, because if this had happened in production, it would have killed the several Oak shards because they were still on the same database at the time. So we sort of hurriedly tore down test flume and split Oak into multiple databases so that we didn't have the same problem again. Our current half-year shards are approaching 8 terabytes. So if we had them still in single-year shards, we would be at risk of running into this limit again, which is one of those things that concerns us because we don't want to hit limits that knock our log over. In the sort of near miss category, we've had a couple times where we have either had no signer running because we were migrating to a new Kubernetes cluster and had to migrate the workloads over and something went wrong. So we had a period of time with nothing signing, which leads to an increasing merge delay, which we'll talk a little bit about later. And we've also accidentally run multiple signers at the same time, which you're not supposed to do. Again, usually because of stuff like migrating to a new Kubernetes cluster and the etcds aren't wired up properly for their leader election. But we haven't killed a log yet, so I'm cautiously optimistic we will continue to not do that. There are a couple interesting ways that logs can die, and this is sort of the things that we're worried about frequently. The maximum merge delay is sort of the thing that is our continual haunting ghost that we have to worry about, because if something sort of goes wrong, we accept some logs, we accept some certificates into our log, and we don't merge them, then we sort of have this commitment to have them in there in 24 hours, which means that we have to have a 24/7 on-call and respond at all time of the day. Other than missing the MMD, there's other things that can go wrong. Corruption of the log data itself. I think Yeti 2022 had a bit flip. There's other sorts of corruption that have happened. Mammoth 2024 H1 had a disk fill, which caused some database corruption and led to some unmerged certificates, which isn't great. There's sort of generic security problems. DigiCert's log 2 had their configuration management system compromised, which potentially exposed the private key for the log itself, which is sort of a concerning thing that is something that we're worried about the complexity of the log, because the more components you add, the more things you have to secure. So that's something that we want to really focus on simplicity for security's sake. And then downtime. The whole point of CT is to make the data available. I think one example from 2023 was Nimbus's log from Cloudflare went down when they had a power-related data center thing that brought them down for a couple days. I think they did end up missing some MMDs, but we decided as a community to allow them to live. But Let's Encrypt does not want to be in a place where we have to, pray that our logs are allowed to live to Caesar. And so, we're worried a lot about these things, which means we have a lot of alerting on our logs, which has a flip side of we have a lot of alerting on our logs. And as a team, I was getting woken up by a pager way too much. It's sort of in 2022 and 2023 was probably one of the biggest pain points in our on-call rotation as a team. And so we really started to think, how can we do better? I already mentioned ctile, the read proxy. That was like the first thing we did immediately to reduce that read load to make sure our scale could support the read load we were getting. But we still had a bunch of other things we were worried about, including the merge delay and just the generic complexity and the difficulty of operations of having to run these Kubernetes clusters and etcd clusters and the various components. So we decided that we wanted a new simple CT log operation targeted just for CT, for our use case that sort of met our needs precisely. We had been running this CT log for 5 years, and we had formed capital O opinions about what we wanted. So on our wish list, number 1, we want it to be simple to run. We want more CT log operators to exist, so we want it to be easy for us, but we want it to be easy for others. And that means we want a cost-efficient, simple to operate, low barrier to entry log. And if we're going to go through all of the effort to make a new log, it really needs to be dramatically simpler, dramatically more cost-efficient. So we're not just looking at Trillion, which is great software, but we're also looking at all the bits that we run around Trillion, like the etcd for leader election and our RDS databases on Amazon. It's the full ecosystem of components. Kubernetes, I don't want anymore, if I can. We want to get rid of merge delay. So it's one of our biggest fears with CT because we accept add chain requests and then fail to merge them. We're in a bad situation. We just don't want to have it. This has been discussed over the years multiple times by different parties, that we think a CT log should be able to sequence and sign fast enough that we can avoid returning SCTs until after the entries are already in the log. And that really helps us with the simplicity goal, because me, as a groggy engineer woken up at 2 in the morning because my log is returning 500s, I can be assured that I'm actually not worried about missing merge delay or worrying about unsequenced data because it doesn't exist. Like, I can just fix whatever is causing those 500s and not worry about any additional remediation items that I might need to do to resequence things that have been lost or something. I think a great example of this is one log that had its disk fill up earlier this year, had accepted some SCTs, and the table got corrupted and those entries were lost. And that's sort of failing the goals of CT of putting it in a log and trusting that it's there. So with no merge delay and the throughput of CT, which is sort of 100 certs a second or something, we think we can handle this with a single process. And that means it's a simple, no microservice, no RPCs, no failure points, one piece of code that runs. We can monitor, we can see how CPU usage and memory usage is, we can look at its log files, and we don't have to worry about failing leader elections or worrying about the complexity around it. And with a zero merge delay system, there's no coordination needed for sequencing, so it's sort of pushed together into a more simple system. The next on our big list of wish list is we specifically wanted to use object storage to store our data. Up until now, Oak and the predecessor logs we tried to run before Oak, which I didn't talk about, but this is not the first way we tried to set it up, and the first couple didn't work nearly as well. We tried some sort of MariaDB horizontal scale, some sort of system, and it hasn't quite been a great alignment. CT logs are append only, they're immutable. And a relationship is not really, a relational database is not tuned for that. It supports fancy queries, updating rows, doing big join operations. That's not really what we're doing in a CT log. So, the cost of running these big databases isn't well tuned for what we want out of a CT log. We already had great experience with the ctile cache running an object storage backed read proxy, and so we wanted to push the actual log to storing its data in that object storage. For us, that means AWS S3 because we're hosted on AWS. But I think at this point, object storage is a bit of a generic commodity. Our hosts here at Google have a version called Google Cloud Object Storage. That might not be right. But there's also open source projects like Minio and Ceph, and commercial offerings from data center storage vendors. if you are like, doing it yourself in a data center or something, scaling out Minio on a bunch of Dell servers you buy is a lot easier than scaling out a big horizontal MySQL cluster too. So even if you're not in a cloud environment, it's still a great option from an operations point of view. So we had this design in mind of a single writer backed by S3 and maybe some horizontal scaled readers serving the classic CT read APIs. But we started chatting this design around, in particular to Philippe, and we realized that we could actually be more ambitious with this. Other transparency systems, such as Go's checksum database, had a newer design based on tiles. You've certainly heard about the static CTP API so far today. So we started really thinking like, well, actually, yeah, our storage format in this object bucket doesn't have to be served via some modified version of ctile. We can actually expose that directly. And as an operator, that's really exciting because a CDN backed by an object store is commodity technology. It's cheap. I can scale it out. I can switch vendors. I have lots of tools to deal with the data, whether that's rclone to sync to another bucket, cloud native operations to copy and back up data, or just like rsyncing it to a file system and putting an Apache in front of it. The actual tile format is pretty interesting. Trillion uses a tile format internally, and you've heard about this a lot, but you have these nice, easy to reason about files that you can work with through any of your normal file mechanisms. My lovely diagram here shows tiles of width 4, but in the actual CT static API, they're 256 wide. The yellow nodes that are sort of in part of these interior trees are omitted for storage compactness because it's a Merkle tree. You can sort of hash up the tree. And then the final layer at the bottom, the data tiles, are just the certificates in their own files. And then you get nice, clean HTTP paths that map into these. So that top tile is sort of level 2, tile 0. And then that its first child to the right is level 1, tile 1. And then level 0 is the one directly above the data, and then your data at the bottom. So this is like a really clean, easy to work with format. And like I've already written a bunch of tools that can work with this in a way that's sort of nicer than having this fancy REST API for the different things. There is one thing, though, which is that this sort of offloads some of the complexity of inclusion proving to the clients who have to know what tiles to load, construct them, and then do these things. And there is one bit that's sort of hard to do with tiles, which is the RFC 6962 endpoint get proof by hash, which given a certificate's hash returns the inclusion proof. As someone on the internet, if you have a certificate, you want to verify its inclusion of a tree, you can just take the hash of that cert, call this API, and get an inclusion proof. With just a set of tiles, there isn't really an option to do that. So as an alternative for the static CT API, there's an SCT extension which contains the index in the log of where that certificate will be sequenced. So you can take that index, calculate what tiles you need to load those tiles, which is, again, a nice, cheap, and efficient operation from a CDN and caching endpoint, in contrast to get proof by hash, which I can't cache across lots of different certs, because every single cert is going to have a different get proof by hash return value, so there's no cacheability there. So you take this index, you load your tiles, and you get an inclusion proof. This also makes detection of misoperating logs a lot easier, because I know where, as soon as I have an SCT, it is supposed to be in a log. You don't have to wait 24 hours for the maximum merge delay to decide that a log is operating. As soon as the log head moves past that index and you see there's a different cert in that thing, that means the view has split. Or if a log is sitting stuck at an old checkpoint and hasn't progressed far enough, you can immediately see that SCT is missing. So this both makes it easier for us as an operator, for log monitors detecting it, but it does make it a little harder for some people who just want to verify a cert is included in a tree. They need a bit more code. This is using the extension field on SCTs. That field has always been there, but we haven't used it up until this point. So that's a potential point of incompatibility that I don't think is going to be a problem, but as we get into the nitty-gritty, is something to consider. So we have this design. We want a single writer for simplicity of operations, tiles stored in object storage behind a CDN with no merge delay. So that brings us to Sunlight, which is the implementation that we are currently running. So we partnered with Philippe here in the audience to lead the design and implementation with feedback from other members of the certificate transparency community, including Trust Fabric and Chrome here in the room, SigSum and others who, we want to build this thing that starts to look more like other logs. So it was important to collaborate with a lot of different people. It exposes the normal CT add chain and add pre-chain endpoints, so CAs can submit today, same as they always do, and monitors can start consuming the static CT API. In contrast to the last architecture diagram I had, Sunlight is dramatically simpler. Instead of 100 pods and 7 VMs, I have one single process on one single VM. Reads go straight from my CDN to the S3 bucket. Writes go to Sunlight. Sunlight has two dependencies, one of which is the deduplication cache, which is stored on a local network file system, which is just a SQLite, which ensures that if you add the same cert to a log twice, we can just return the previous index. That is actually non-critical. If the file system fills up, which one of our test logs had happen, then it just will accept it into the log again, or otherwise, not fail, which is a big contrast to the Mammoth 2024 H1, where a full file system killed the log. This actually ran with a full file system for like a whole week before I even noticed, which also meant I needed to fix my Prometheus alerts, but that's a different issue. As well, there's the lock backend, which runs in DynamoDB, which just prevents accidentally running 2 copies of Sunlight for the same log. It's a safety mechanism. I mean, I'm not going to run multiple writers, but if I did, the DynamoDB prevents that. Unlike the etcd cluster, I don't have to run it either, which is important to me because we have messed up our etcd cluster more than once. The compute resources are relatively tiny. I'm running on a single AWS T4G small, which is 2 vCPUs at 20% burstable capacity and 2 gigs of RAM with 100 gigs of EBS local storage. And then the object storage, approximately the same as what we had for CTILE already, so it's not an increase. And then the CDN bandwidth, which also should be smaller because the tile representations are both compressed and less verbose than the classic CT get entries API, so we expect significant bandwidth savings on that side. Though actually, on bandwidth savings, this log is a lot harder to knock over. So it could be that the misbehaving scrapers, which currently cause us to fail and crash, instead now successfully just use up a bunch of our bandwidth. I think that's a trade-off we're okay with. It might make the bill go up, but the logs keep running. I think that's probably good for the ecosystem overall, but we'll have to see how that goes. We're currently running 3 instances of Sunlight. They currently have 2025 shards provisioned, and we'll have 2026 ones in the near future. Twig is our test instance that our staging environment submits to. And if you're another CA who has your own test instances, you're welcome to submit to Twig as well. Sycamore and Willow will become trusted logs once the CT log programs are willing to accept Sunlight logs. And Let's Encrypt production environment is currently submitting all of our pre-certificates and all of our final certificates to all 3 of these logs. So that's sort of a full web PKI worth of traffic that we're observing on these. Just because I would say Let's Encrypt is about sort of half the number of certificates issued to logs. So normally, we submit to one of our own and one of another or 2 other operators. So all of our logs having all of our certificates is sort of a multiplicative traffic effect. So we're pretty confident at this point that this is basically working. These are still a little bit of a test log. I think some of our CDN caching settings and things might not be quite right, but we're really interested in getting these going. So of course this design has some trade-offs, and I want to explicitly address them. The first thing is we have this single writer with no leader election. It's just a VM. So as Joe mentioned earlier, the CT log policy SLO is 99% uptime, which is like not that high of an uptime. And we think that even without a leader election, if a VM fails and we have to wait 10 minutes for Amazon to reschedule it to a new instance, that like we're well within that, plus the regular maintenance. We're actually just like, if we deploy a new instance, we just tear the VM down and replace it. So it does go down for a couple minutes during that time. So, that's an interesting approach. I think we'll have to see how that goes and how the ecosystem tolerates it. But we're, certainly interested in trying. Again, because of simplicity, it's a lot easier to run the log that way. I talked about the no merge delay. We're really afraid of it. It is a source of headaches and concern and potential ways to kill a log. So we want to get rid of it. But the thing is the merge delay serves a purpose. So with no merge delay, there's an obvious corollary, which is that you have to wait for the merge. So on Oak, in Trillion, the 75th percentile latency is 100 milliseconds as it just writes a row unsequenced to a database. With Sycamore, that 75th percentile latency is 1 second. And this is measured from Let's Encrypt to 2 logs running in the same AWS region. So there's sort of, similar, from the CA perspective, latency and everything. From our perspective as a CA submitting to a log, we think 1 second is acceptable. We use the ACME protocol. The finalize operation, which is when you submit a CSR and you get back a cert and is where the CT log operation happens, is at least in theory asynchronous, though we've had some bad client software, so we actually haven't enabled asynchronous finalization to avoid breaking Plesk. But we are okay with this within our own margins of things. This is something I really want to hear from other CAs about, is 1 second to submit to CT okay? If you're issuing 10 EV certs a day by hand with an operator clicking a button, then I would suspect it is. If you're Let's Encrypt and we're fully automating, we think it's okay for us. What about someone in the middle, maybe running off-the-shelf software or running medium volumes? I'd love to hear discussions from people about this. We could potentially mitigate and lower this if that's required, but that's something I'd love to hear from other CAs about before we start trying to tackle that time down. Of course, the biggest thing is the static CT API requires the log monitors to update. It's a new API. It's a big lift. It's something that we're concerned about. Some log monitors like Census have already started monitoring our new logs, but there's a long list of them. I think based on our traffic, we estimate about 10,000 people monitor our logs in terms of monitors that pull the full tree out. So, I know of 3 of them right now that support it. So that's, another 10K minus 3 log operators to go, or monitor operators to go. The other thing that about the static CT API is this SCT extension. We're always worried about adding data to a field that hasn't been used before because maybe I've certainly Google searched how do I parse an SCT and found some janky Python on GitHub. And I don't know how many people are running those janky GitHub scripts that are, not really maintained. If you are, you should use the PyCA cryptography project, which is a nice, robust SCT parser. So there's a bunch of trade-offs that we're making with design. Are they worthwhile? We think so. There's one really, really big reason why we think it's worthwhile, and that we can run more smaller, cheaper logs. So I talked about Oak with 7 compute nodes plus 6 database clusters. With that same infrastructure as a log operator, I can run more logs. And that means a more robust ecosystem. CAs already have to choose between multiple logs to submit to. So effectively, we already have this distributed system that is handling log downtime. And a single, disqualified log from a batch deploy or a meteor strike or a full hard drive isn't nearly as impactful to the ecosystem if we have multiple logs. we can spread these across multiple cloud regions and availability zones that just increases the system's overall reliability. And in fact, on Tuesday, we saw this. AWS S3 was unavailable for 22 minutes in US East 2, where we currently run both Oak and Sycamore. Sycamore just went down. It was unable to sequence because it couldn't write SCTs, so no SCTs got returned to CAs. Twig and Willow, running in different regions, were up, it's fine. As a CA, we can still submit. But on the other hand, Oak's read path was significantly degraded for those 22 minutes. Because we can't handle that read from our database alone, monitors were unable or very delayed in getting data out of Oak. So that means that while we were returning SCTs to CAs and we were well within our maximum merge delay, the goal of CT of making those certificates available widely was not successfully being met. And so in this case, we think that even though in theory those single writer logs might have lower uptime, having more logs in multiple regions with different disaster recovery properties makes the whole system more robust. And finally, I'm really hopeful for a CT ecosystem that has multiple high-quality log implementations which make different trade-offs. We don't think that everyone should run Sunlight. In fact, maybe we'll be the only CA that runs Sunlight, or a new log arbiter will additionally run it. But other people might want to run Tessera. They might want to continue running Trillion. They might want to run some new CT log option that is backed by, serverless compute and a key value store. We've got a lot of variety of how these things can be implemented, and I think that'll also further increase the robustness, reliability from that sort of SRE perspective of software variety, different options, and overall robustness. So where do we go from here? The big thing is that we're running the logs, but that's only really the start. So we need to get log monitors to support the static CT API and to consume those. We need to get browsers trusting the Sunlight logs so that we can start including those SCTs and certificates. Chrome has sort of suggested that's coming soon, and Apple has also said that they intend to support them in the future. And Let's Encrypt is going to begin pulling SCTs from these logs in production as soon as we can. We already are in our staging environment, so if you're concerned about any of the SCT extensions or otherwise testing this code, we invite you to use our staging environment today. As one final bonus thing, Andrew Iyer has released a project called Sunglasses, which provides a proxy that you can get the traditional RFC 6962 CT API backed by a Sunlight log. So if you are a log operator, a log monitor, and you want to start consuming our Sunlight logs today with no additional code, you can just run yourself an instance of this. I'll leave you with a couple resources. Sunlight.dev is the homepage for the Sunlight implementation. c2sp.org/static CT API has the static CT API specification. And the Sunlight channel on the Transparency.dev Slack is where you can find me, Philippe, and others to answer questions about Sunlight. Finally, I'd like to thank the organizations and individual sponsors who help us make our global impact via Let's Encrypt, Sunlight, DivvyUp, and Proximo. Let's Encrypt is a project of the Internet Security Research Group. You can find out about us and all our other projects at abetterinternet.org. And if you're interested in sponsoring our work, you can reach out to sponsor@abetterinternet.org. That's all I've got. So I guess we can, if we have time, do some questions.
Hey, thanks for the talk. You mentioned misbehaving scrapers. I'm just curious to see what kind of abuse you do see in the system and whether it's getting worse, what there is to do about it.
Actually, I think when I say misbehaving, maybe that's not the best phrasing, but over-aggressive is maybe better a phrase. So, we do have rate limits on our current system, which are intended to prevent overload. Some of those rate limits are sort of per IP address or otherwise per net block or per some other heuristics we have. And so, you might not be deliberately misbehaving, but maybe you're just going to decide, hey, I want to scrape all of CT into my data warehouse, which runs on 10,000 nodes in some data center somewhere. So I'm going to set up a big distributed MapReduce job, and suddenly 10,000 VMs are going to spin up and each try to pull down, 1/10,000th of a log. Like, that sounds great from like your data science perspective. That is not so great from my API perspective, as you effectively DDoS me.
I'm curious about the duplication database. I take it that's essentially a list of all the hashes.
Yeah, it's basically a mapping of certificate hash. Well, actually, is it just a list, Philippe? What's the format?
It's a mapping of certificate hash to just the SCT to return.
Okay.
No, the signature is not in it because they're deterministic ECSA signatures.
Okay, so it's just an index, yeah. Okay,
So if you have that mapping from a hash to
so
index,
it's a SQLite database on a local EBS, or EBS is not local, it's a network file system, and it maps the hash of the system to the index of where that certificate already is in the lock.
And
so
then
if
you can use that to support this missing API call to get
Well, yes, but also to know, do I need to include it in the next block, or can I just immediately return an SCT with the index from where it was before? Because without it, or if I reset because I have a disaster, I need to move to another AZ, we don't have a query of like, is this already in the tree? And we don't want someone to be able to submit the same cert over and over and over again and fill up the tree, if that makes sense.
So if part of the question was, can't you use that to implement get proof by hash? The difference is that this one, as he said, is a best effort cache. So you can drop it on the floor and still be correct. That API is not best effort. If you do offer that API, you need to actually answer the client if it comes with a valid hash. Yeah. So you can't use it for that.
So the Sunglasses project, which I mentioned, is a proxy that does support it. It has its own database to maintain that that API. And so if you were to build a unified system, then maybe you could have a more robust database. But one of our goals with Sunlight was to really maintain that simplicity, make this a best effort cache that I can throw away if I need to. Specifically, our logs are sort of in one region in AWS, but the EBS file system is a specific availability zone. So for any reason I need to move AZs, I have to worry about syncing that data over, which I don't really want to do because that's going to be a disaster recovery operation. So having that only best effort is fine for that, but not fine for serving get proof by hash.
Do you have any metrics on how many monitors are continuously pulling the logs?
I based on some numbers I have, I would estimate about 10,000.
All right, last question, then we'll go to break.
But that's really squishy because maybe one monitors multiple entries and IPs, and so yeah.
This is probably a very dumb question from someone who doesn't have much context, but that sounds like a good use case for something like BitTorrent, shipping out these tiles and making sure that people can download them without hammering you. Is there any truth to that?
No, I mean, that actually is a great point, and that's something that, I think, BitTorrent specifically, I think, is an immutable set of files. I don't think you can really append quickly, but because this data is all, has a signed tree head, we could easily have some sort of replicated gossipy system to distribute it. Whether or not that's worthwhile as a we want to offer this as a trusted log operator, having a worry about a potentially community operated instances or something that might misbehave. That adds significant I guess security or trustworthiness perspectives, but certainly. Because the data is really just a set of files, there's lots of ways you can distribute a set of files.
Okay, I'm sure you have many questions. So catch Matthew in the break this afternoon, but thank you so much for pulling back the curtain. All right, we'll take a break now and resume at 11. I know we're running a little behind, but it's all good. And enjoy some coffee. we're adaptable. So, and I just want to talk a little bit after lunch. After lunch, we will be moving into our breakout sessions. So how that's going to work is the front of this room will be for the CT breakout. So if you're interested in CT, stay in this room. We'll be pulling that curtain and separating the space in two. So the back of the room will be the focus on binary transparency, which will include things like SIG-store and SIG-sum, and maybe taking a bit of a wider look at that whole area. And then we also do have another room for key transparency, which is in a different space on a different floor. And it is a smaller space, and we'll have to figure out how to escort folks who want to go to that. But yeah, we'll share more just before that session. Maybe I'll do a quick show of hands. How many folks are expecting to go to the CT room? Great. And you don't have to fully commit, and you can change your mind. How many folks for binary transparency? Trying to tell if folks have raised their hand twice, but yeah, that looks good. Okay, and how many folks are interested in the key transparency room? Okay, this is all manageable. Yeah, no, thanks for this indication. Okay, we are going to resume our talks now. And I want to give a shout out to a community member who couldn't be here today, Ryan Hurst. He was active with the planning and unfortunately would have loved to be here but could not be here. But he did see JP and Chervine speak at an event recently, and he was really enthusiastic about bringing them here to the Transparency.dev Summit. Unfortunately, JP could not make it, but we do have Chervine here. And yeah, it's going to be, we're looking into different areas for transparency. So yeah, I hope this talk sparks a lot of interest and some new conversations. So please welcome Chervine.
Thank you. So yeah, I've been involved in transparency for well over 24 hours now. So I feel very confident speaking in front of you now. So what I've actually been doing this past 5+ years is building a cryptocurrency custody solution for banks. And we use these things called HSMs. Now, HSMs are where you put your private keys if you're a bank. In reality, they're essentially Linux computers from the 80s with a cryptographic coprocessor, and if you try to open them, they blow up. That's all they are. The traditional way of interacting with a key that is stored in an HSM is you have some credentials on a software server. The HSM has your private key. You request a signature. You get a signature. Now, this has a few issues. It looks super simple, but it does have a few issues. And that's, well, the credentials are in a software server. If you break into that, you now have a signing oracle. Never great. So we've been trying to turn these kind of brainless, stateless machines into something a bit more powerful. And the very first step to do that is trying to add some state. Now, by state, I refer to essentially a set of rules that a request must satisfy before being successfully processed. So that way, even if you gain access to the HSM and you can send requests to it, you can't exactly fake those rules being met. A classic example that we've used in the past was we load 3 public keys into our HSM. Any request that makes it to the HSM must be signed by the corresponding 3 private keys. And if they aren't, then the HSM just doesn't process the request. That's great, works well, but it's super, super inflexible. What if you want to modify that state? Then you need to modify directly in the HSM. If you make that step too easy, well, it's not much of a security benefit. If you make that step too hard, no one's going to ever use it. So we fixed that by introducing a kind of meta state, which is we keep three public keys in the HSM, and instead of signing the request, they are in charge of signing state, which is, again, the rules, the workflows, whatever. So we introduced the role of administrators, who are in charge of essentially validating state. They sign the set of users, they sign bindings between users and groups, they sign transaction rules, and we bundle all of that into every single request. We send it to the HSM. The HSM verifies that the request matches the state that it's been sent. It verifies that the state is actually signed by the admins. If everything checks out, then it signs the transaction. Again, great. That's worked for over 4 years before we've hit any kind of limitation. But there are limitations. And the main one is that, again, we have 3 admins. These guys are in charge of validating users. They're in charge of validating binding from users to groups, in charge of validating transactions workflows. We've added a lot of stuff that they're actually in charge of validating. It becomes a bit too much. In practice, we've seen that they almost never verify anything. They just press OK. They just sign. This doesn't work. So we're trying to make it a bit easier for them. And how do we make it easier? We split them up. Instead of having 3 admins that are in charge of validating everything, we want to split them into, OK, so you guys are managers for users. You only verify users. You guys are managers for groups. You only verify that the users in your groups are actually correct, etc. And we also don't want them to be all or nothing. We don't want them to validate the entire state every time there's a single modification. We want them to verify that modification, and modification is applied to the state. And to do that, it's pretty simple. You add rules about modifying the state into the state. You send the request that modifies the state to the HSM. The HSM verifies that the request is valid, modifies the state accordingly, sends it back. Great. But there's still a few limitations. We've never actually implemented this in practice because it doesn't work for a very simple reason. We are sending the entire state on every request. That's too much. There's way too much information for that to be sent in every request. We can't store it inside the HSM. The HSM doesn't have enough memory. It doesn't have enough persistent storage at all, so that little memory. So we want to trim that down. So we want to, for every request, instead of sending the entire state, we want to send only the relevant parts of the state. So for instance, imagine a transaction that only 3 users need to approve. You don't really need to send the 10,000 users. You just send the 3 users. You say, oh, OK, so those guys are in the state. And you send them. The HSM verifies that they're in the state. And you're done. And that's kind of this model. We only send the relevant state. Now, we're trying to solve 2 problems that are kind of contradictory in nature. Our first fix was like, OK, so the HSM signs the new state. So clearly, it needs to have access to the state. And our second fix was like, hey, we never actually give the HSM the full state. So how do we actually fix that? Well, you know the answer. It's been the answer for the past 24 hours. Merkle trees, yeah. But not only Merkle trees, because Merkle trees have a very tricky limitation. They are great for transparency logs because they're append only. I need to be able to delete stuff. When you start modifying a tree arbitrarily, without rules, that tree becomes skewed. When a tree becomes too skewed, you no longer have log-n access patterns. You have linear access patterns. And that just, why do you have a tree? The classic example of a tree that's actually balanced is the traditional red-black tree. And it's the classic example because it's the tree that's in the Introduction to Algorithms book that everyone here owns at least one copy of. And it's a very simple type of tree with very simple rules governing how to insert, how to delete. And as it turns out, all those rules are based on an operation called rotations. So essentially, rotation works kind of like this. So you want to rotate x once to the right, so x goes up, y goes down. You want to rotate y to the left, y goes up, x goes down. The funny thing about rotation is that here with like the small letters A, B, and C, those are subtrees. We never touch those. If they're Merkle trees before the rotation, they're still Merkle trees after the rotation. And we can kind of combine the Merkle and red-black properties onto a single tree. And what that lets us do is actually, given a partial tree, so given like an inclusion proof on a node of the tree, we can actually start inserting inside that proof. So instead of insert, like I have 3 users I want to add to my set. I have 10,000 users. Instead of having the 10,000 nodes tree, I have the path that my users are going to be inserted in the red-black tree as a proof. I reveal that, which is like 10, 20 users. I insert into that, and the resulting root of the tree is the same as if I had inserted into the full tree. So I have a bunch of examples, but we've decided to turn half of the talk into a conversation session. So I'm going to skip the very nice graphs. But essentially, yeah, we start off with a tree that has a few entries. We add and we add them into the compressed version of the tree, and we see that the root hashes actually match. They're, well, not here, but in that slide they match. Yeah, so what we actually are able to do is essentially we now store all our data as red-black Merkle trees. We have one tree per type of entity, and we are able to both send only the relevant states when we're processing requests, but also when we're processing kind of the meta requests that are affecting state themselves. And that lets us essentially turn an HSM with 2 megabytes RAM, no static storage, into a database, which is very, very nice because we can start enforcing a variety of checks that we would have never been able to enforce before, all essentially right where the keys live, where the keys live. So yeah, it's essentially the best trade-off we could come up with, and I hope you found it interesting. Now, I'm in time.
Okay, yeah, as Chervine mentioned, we wanted to just open this up a little for a bit of discussion around HSMs and transparency. And yeah, I was going to just go to Phil first, who I know has lots of thoughts in this space.
Thank you very much. So how do you send the rules to the HSMs that that they would have to enforce?
At first, we send them along with every request. But now, essentially, we still need a way to bootstrap the system. So how we bootstrap the system is we still use the old mechanism of having 3 admins that are inside the HSM. And these guys sign essentially the initial state of the system. So that includes the users, the transaction rules, but it also includes the rules on how to modify the state of the system. Once this initial bootstrap step has been done, these guys can go on holiday forever. They can lose their keys. We don't really care because their job is done. They've bootstrapped the system. They can still come back in case of emergency, like you've dropped the DB, because again, we can't really store the actual state in the HSM. What we store is like a counter and stuff like that. So if you drop your DB and you lose all your state, well, you can't really reconstruct the Merkle tree. So you still need someone to come over and do a recovery, and that's what these guys are for. But that's once they've bootstrapped the system and the state is set up, they're done.
Basically, you have to trust them. You have to trust that they won't like send fishy rules or.
So the good thing about the banking environment is that they have a ton of controls, and the initial bootstrapping is done during the key ceremony with many auditors present in a very, very constrained environment where they have to write everything down, everything is filmed, they're in a bunker. So these guys have very, very little incentive to, well, not incentive, but they have very limited room to misbehave. If they actually manage to misbehave during the key ceremony, better tactic for them would be to misbehave during the generation of the keys, because that's what controls the funds. So, yeah, we assume that this kind of trusted setup makes them, yeah.
Thank you.
So Al, sorry, I'm going to put Al on the spot a bit. So, in your keynote yesterday, you talked about demanding transparency. Like, do you have any thoughts about in the space, like based on Chervine's presentation? Where is the role?
Well, okay, so I mean, thank you very much for this insight into your world and the tight box in which you live. We haven't explored this space very much, but we sort of thought about some of it in the abstract. And one of the constructions that we sort of came up with, and actually Phil can talk perhaps a little bit more about this in some work that he's done with another group. One way to sort of bring transparency to this sort of construction is by having a HSM which doesn't take RPC requests and instead consumes requests to perform actions that are present in a transparency log, right? And you have to, therefore, log your intent to have a thing signed. And so you sort of avoid trying to record audit tracks after the event. What do you think?
That makes perfect sense. The only caveat is that we're in a very private environment. So running a full log is kind of similar to having, essentially one process that says, hey, I'm in charge of sending stuff. I'm the trusted source. I'm recording the data. And that's actually very similar to what we already have. So among the rules of all the inside the states, there's a very implicit one that isn't really set. And it's that only our trusted backend can send actual requests, and only those requests will be processed. So if anyone tries to bypass the backend, well, it's a lot more effort. Essentially, it's akin to stealing the private key for the log. So we already we already have something very similar. It's just not built inside the log. It's already built inside the backend.
Take a question.
Hi. Something I don't understand about the HSMs, or well, I guess it's an opinion. If you have, imagine a computer with unconditional measure boot, where you have a unique per device secret, and you take inspiration from TCG dice, and then you contextualize the key material of the running system to that unique per device secret and the hash of your first boost stage, which then pivots to the second boost stage, and so on. So you get a increasingly contextualized key material. That seems to me like it's a simple and clean solution, both from a hardware perspective, because you don't have to do verified boot and put asymmetric cryptography in the boot ROM. You can get away with a smaller boot ROM, smaller die size. Why aren't HSM vendors doing that instead of, or is this? Can you do it? Can you do that with most HSMs, or is it really is it a clunky interface, or do you get a general computer?
I'm kind of confused about the question. The HSM itself does do the whole secure boot thing with the correct chain and things, and we're able to just upload software onto it. Is the question about the key ceremony thing?
No, I actually. So let's put a distinction between measured boot and verified boot, where they both go through the load into secure memory, hash, and then it's either verify or measure, and then it's execute. So in the verified boot case or secure boot, which is the same thing, is you have a trust policy where you verify the next stage. But in measured boot, which you can do with TCD.ice or TCD TPM or SCV SMP or Intel TDX and so on, it's you always load the artifact, but you send the measurement somewhere, so you can do remote attestation. But you can also do local attestation or use the measurement as a way to do a KDF. So the key material that you give to the workload that you just loaded is contextualized, and so it, whatever application you load onto there has its own key, and that way you don't necessarily need secure boot. And I guess my question is, can these devices do unconditional measured boot?
So they're really not meant to be used as TEs. We are grossly misusing them as TEs. So I'm assuming that their entire boot process is correct, but in reality what happens is that we're loading essentially a Linux binary on a regular Linux OS that just happens to run in a tight box. When that then this process is executed normally, and all the actual cryptographic functions are just routed to the second chip, which is the encrypted, cryptographically secure chip. As far as generating key material specifically for our application, that's actually something that we really, really don't want, because we want to have backups. We really need backups of the system, and we don't want to be able to extract them from the running system, because that would be a target. So we need a way to generate them completely safely outside, then load them in. So that I hope it kind of answers the question.
Thanks. Can I just get William to get set up? And sorry, I'm going to go to Rasmus first.
Hey, I'm curious about the red-black Merkle tree.
Yes.
I mean, there's a bunch of different authenticated dictionaries out there, right? And this would be one example of it. And I don't think I usually see like a red-black Merkle tree. So why did you choose that one? And how do you compute the different hashes in the tree? Because that can be quite subtle when you start moving things around.
So the reason I picked red-black Merkle trees is that I thought of them. I knew I needed membership proofs, and I don't really know all the literature. I'm very much a software engineer. I knew about Merkle trees, and I just needed a way to make inserting into them nicer. So if there are authenticated dictionaries that allow you to do this kind of stuff more easily, I just haven't stumbled onto them. But honestly, this works surprisingly well. The hashes are just SHA-256. And
have you done a security analysis on your structure?
I mean, it's a Merkle tree. What do you need to?
So when you start moving the nodes around, interesting things can happen. So there's a bunch of academic work on this. So depending on like how do you hash the nodes, what is in your root, you might not get the properties that you expect. So I'd be happy to talk more about it offline.
Yeah, definitely. I'm interested because it really sounds like you're just hashing stuff, and hashing stuff should work.
Okay, we'll take one more question, and then I'll let the rest of the discussions happen at lunch.
I think if I understood your presentation properly, the problem is how do you make sure that the HSM is used by the right client, right?
Yeah, we're trying to enforce workflows as close to the keys as possible, essentially.
So couldn't key transparency help you there, where you would encrypt the data you want to sign and put the key in the key transparency log, and then the HSM can check that?
And eventually it all comes down to we need someone to sign the data that's sent to the HSM, and we need that data to be verified somehow. Again, very new to the transparency space. So the idea of key transparency, if it's mapping users' identities to keys, that part is actually in a very closed system. Again, like we're talking a single company. That's fairly simple to do. We can do that like many different ways. The issue is getting the HSM to know that that's trusted without being able to rely on a single point of failure. So if you're thinking about logs, you can say, okay, so there's this log, and there's a bunch of witnesses, right? And that's kind of what we do. Like we have this state, and then you can think of the admins as witnesses to the state. They say, okay, so I've seen this. This is correct. I verified it. So it's very similar and similar enough to the point where I think eventually, like if all of this is super standardized and there's like generic frameworks to do all of this, yeah, sure, why not? But in a completely closed system, it was easier for us to just handle it.
Mm-hmm. Yeah, I know there's more questions and more discussion, but I'm going to have to call it there. But thank you very much, Chervine, for seeding this topic. Okay, so we're going to continue in our theme of let's get transparency everywhere in all different spaces. And yeah, I'm really excited to hear William speak. I think this is a great transparency success story. So I'll hand over. Please welcome William.
Hey, everyone. All right, thank you for having me. Yeah, I am pretty excited to talk about this. So sort of the scope of this talk is I've done a lot of sort of applied work in transparency over the last few years, helping bring it to ecosystems like PyPI and Homebrew. And this talk is supposed to be more of like a scattered-brained, here are all the things that we think about when we're trying to secure these ecosystems. And here are some places that I want people in this audience to think about where transparency could be useful or applied in the future to reducing the amount of latent trust we put into packaging managers, packaging indices, that sort of thing. So sort of going to be like a stream of consciousness, hopefully. If we haven't met already, my name is William Woodruff. I'm an engineering director at TrailBits. I run the open source team, which is the team that's responsible for contributing to PyPI, Homebrew. We do a lot of work on Python and Rust cryptography. And then more generally, TrailBits, we're a cybersecurity consultancy, roughly half remote, half in New York City. We do a whole lot of different things, and I'm happy to talk about all of them, but I'll do that offline. Yeah, so as a sort of high-level agenda, I want to talk a little bit about open source and trust, do a quick background on Python packaging for people in the room who aren't super familiar with it, talk a little bit about like what it means for the Python community to trust PyPI, why we should even want a zero-trust PyPI, and then how do users currently trust it, et cetera. And then both what we are currently doing and what we plan to do and what we could do to further reduce trust in PyPI 1 year from now, but also 5 and even 10 years. So first, I want to talk about open source and trust. I think everybody in this room already knows sort of this. I'll kind of breeze through it. Open source is everywhere. Everything we do these days, to a sort of first approximation, has some amount of open source in it. And we all trust. By the way, I talk really fast, so if I talk too fast for you, please just raise your hand and I'll try to slow down. But by default, I'm a kind of fast talker. Yeah, pretty much everything we do to a first approximation has some amount of open source in it. And an unknown, uncountable, and indeterminate number of people are maintaining that open source for us. People who are qualified to do it, and also people who aren't qualified to do it. People who we don't know their qualifications, et cetera. And as a matter of, like, as a facto state of affairs, we trust them whether we want to or not. one of the things that we do in open source is we realize that the trust is actually a paradox when it comes to the things that we consume. In order to trust open source more, we actually need to be able to trust it less. So we want to be able to qualify and constrain the ways in which we trust it to assert the trust that we currently latently assume. There's various numbers of ways we manifest this, but the one that comes to mind a lot for me is in sort of traditional package signing or code signing setups, you have a keyring of trusted signers. And a really classic bug is transitive trust across that keyring, where you're really supposed to trust each member of that keyring to sign for one specific thing, but instead you trust the entire keyring to sign for everyone. And so someone who you trust to sign, widgets now signs for Chrome, and that's not really what you intended. So with that in mind, let's talk a little bit about PyPI. So PyPI is the Python package index. It's pronounced PyPI. It's the default source of Python package distributions, which are the things that you pip install when you are programming in Python or in pretty much anything that integrates with Python. One thing that I think is a little bit surprising to people is that it's not a dumb index/host. It's not a thing that you just dump files onto. It does a bit of processing behind the scenes. Not a lot, but a little bit. It has user and organization management, so you can create an account on it, you can create an organization on it, and you can manage those things. And then the namespace, while not closed, is in fact administered. So there are operators on PyPI who every day receive reports of spam or malware and actually take those things down. So we do in fact curate the namespace, although the namespace is not curated for quality, which comes into play later because some people actually assume that it is curated for quality. So with that, I want to talk a little about trust within PyPI. PyPI, being the sort of de facto index, occupies a unique position of trust within the community. People assume these things. They're not things that are they're taken for granted. We have a basic integrity sense of trust, where people assume that when you download a file, if you download that same file tomorrow, the digest of that file does not change. Whether or not the contents of the file are good is sort of a separate question, but basically the basic package integrity does not change. There's also a basic assumption of authentication integrity. Users and orgs can only upload to projects that they already control or are given control over by someone who previously controlled them. There's this more fuzzy availability trust assumption, where people assume that any time of day, anywhere on Earth, pip install works. And this isn't, in fact, always true, but increasingly we're seeing people assume that it is. And you see a lot of sort of embarrassing corporate failures happen because people try to pip install and don't have backoffs or failure modes set in place. And then finally, the scariest one, which I can't impress enough how shocking it is that people believe this, but they really do, is that presence on PyPI implies quality and trustworthiness. And I want to bring this in because this is not something that we can solve abstractly, but we can. I think there are interesting things we can do in the transparency world that make it harder for people to abuse this assumption, even if they still make it. So with that, I have a sort of way that I order these things in terms of easiness, and then extremely hard at PyPI scale, and we'll talk a bit basically about how the way I think about these things is that an attacker who can compromise one or more of these properties is both a security and a sustainability risk to the ecosystem as a whole. So obviously, from a basic security perspective, they can break into machines, they can steal things, they can do anything that a malicious agent would do. But also, there's a sustainability aspect to this, in which the modern software stack is built around the assumption that PyPI is available and that everything that you use to build your applications remains available. And if an attacker can undermine that trust, that latent trust in the availability of the ecosystem, they can do sort of a large degree of damage to the stability that we all assume in the software that we use every day. So I think a lot about that as well in terms of trust. So with that, I want to talk about how PyPI is doing right now. So on the package integrity side, things look pretty good. I frame this as can a malicious or compromised PyPI serve you malicious files? The good news is that for a while now, PyPI, wasn't always the case, but PyPI now serves files over HTTPS, so transport integrity, fine. We promise that files don't change after upload. And files are served with their digest ahead of time, and then you can check that digest. This itself doesn't really mitigate an attack, but you can use it to sort of pre-plan, especially if you already have the digests. So in theory, clients like pip can audit PyPI for package changes via hash binning. So they'll download the dependencies, and then at a future point, recheck those dependencies for changes. However, Python, because it's a pretty old and legacy-driven ecosystem, doesn't have a standard packaging lock file format. And so the number of clients that actually do this is pretty small. So this is an area for obvious sort of non-transparency, but security nonetheless improvement. But then something that I also want to flag, which I think is kind of surprising and I think does have transparency implications, is that while files themselves are immutable in PyPI, releases are not, and releases are made out of a sequence of files. And so one thing that an attacker can do, which I personally think is pretty surprising, is they can upload a more precise specifier for a release. So instead of an SDist, they can release a wheel for a specific subarchitecture, and then anybody who's on that subarchitecture will instead resolve that newer wheel file for that same old version, which means that even if you're checking hashes, it'll appear to be like the tofu hash, where it's the first one. You'll just assume it's good. And I think this is pretty surprising from an index malleability perspective, where you sort of assume that a release is created and then is frozen a certain point after its creation or after its upload. And this is somewhere that index transparency in the form of like a Go checksum database could be of service. On the authentication authorization side, again, I sort of frame these things like how easy is it for an attacker to take over a project, and assuming they do, how easy is it for the community to detect that the takeover is malicious and not a authentic transfer of ownership. Again, at a basic sort of non-transparency level in terms of trust, PyPI has had strong multi-factor since 2019, and since 2024, this year, that multi-factor has been mandatory. We've also removed the ability to upload with passwords. You have to use API tokens or trusted publishing now. That also factors in, I'll talk a little bit about PEP 740 and what we're doing on the SIG-Store side of things. That factors into that. And we also have a mature policy mechanism which requires public disclosure of intent to take over a project before admins act on it in the form of this thing called PEP 541. However, this all happens on a public GitHub issue tracker, which nobody, as far as I know, there's no real sort of machine-readable schema to it. You just sort of say, I want this package. And then an admin, some degree of months later, says, no one is currently using it. Go nuts. So not exactly easy to audit, not exactly transparent, other than in a very basic data is public sense. And as sort of probably everybody in this room knows, that kind of innocuous transfership of ownership is exactly how the XC attack happened. Someone said, I want to help. You don't want to help. You don't want to do it anymore. I'll take over maintenance. And that's how we ended up in that situation. Going sort of further down to the not as green set of things. So in terms of availability, I think in terms of, can an attacker disrupt the overall availability and smooth operation of Python? This goes into like the more abstract trust of, can they irreparably damage the confidence the community has in the index? This has several facets to it. One is if an attacker can cause downtime or availability issues to the index, users may temporarily or permanently switch to less trustworthy mirrors that aren't over HTTPS, or they don't provide hashes, or that are in countries that are susceptible to meddling, et cetera. And then even the perception itself of a less reliable PyPI, one where outages, even if they don't cause huge issues, occur more often, can induce worse security practices, like I said, and also in the form of like updating less often. So we want users to regularly update so they get patches to their projects, but the perception of a less reliable PyPI induces poor security practices there. Sort of on similar notes, how do I want to frame this? We have this weird like double edge with PyPI where PyPI, most people don't experience any issues when they pip install. I mean, I think our success rate is well over 7 nines. But as a result of this, nobody caches when they hit PyPI, so everybody just hammers it full on, and they go straight to Fastly CDN, which, to Fastly's credit, performs extremely admirably under the large load of PyPI, and they do it for free. However, as a result, the entire ecosystem has this like latent assumption in it, which is that you can infinitely hit and hammer PyPI, and your request will always be served, and you don't have to maintain a local cache or any sort of local caching mechanisms. And similarly, we have like a supply-side protection in terms of availability, where PyPI can hit the emergency brake and say no more uploads or no more downloads if we're in the middle of an incident. However, this again induces a long-term shift towards distrust in the index, which runs the risk of less secure default user behavior. So again, something that we just sort of abstractly think about. Okay, and then finally, sort of the really crappy thing, package quality. So again, I want to really emphasize PyPI itself being trustworthy in terms of its integrity or availability does not imply that packages on PyPI are trustworthy, but in reality, most users don't know or believe this, even though we say it pretty much everywhere. This is driven in part by Python's culture, which I think is a huge boon, but the belief that Python is a big tent where large independent communities simply don't know really how pip works. They see it as like a magic thing that they type in and they get the features they want. And it's sort of like a curse of success where everything works so well that it can't possibly be malicious because it's just magical. And of course, it's also driven by a little bit of like wishful thinking where, and this is true in practice, 99% of the time, if you mash random packages from PyPI, you're not going to get malware. And so I wouldn't recommend anybody do it, but in practice, users see this and they believe that they can get away with it. Even if things break, they won't be broken in a malicious way. They won't be served intentionally malicious code. This takes multiple forms. People believe that PyPI is curated beyond basic like admin operations, which is not true. It's entirely uncurated, besides malware removal. They also believe that PyPI will remove vulnerable or dangerous things, even if they're not malicious, which is absolutely not true. We don't remove anything unless the user explicitly removes it. And same thing for explicitly malicious malware. We do try to remove it, but there's no actual removal timeline guarantee. If you notify the admins, typically it's within 24 hours. Typically it's within, I believe, even 8 or 6 hours. But we don't actually commit to that anywhere because it's a mostly volunteer-run project. Okay, so that's the current state of affairs. I want to talk a little bit about things that might be more of interest to this room, which is what could we do for a zero trust future on PyPI. So I'll use the same sort of schema again to inform that. So on the package integrity side of things, sort of the most basic, we have this promise of file immutability. And of course, what we really want is to make that enforceable via auditability from the community. So right now, that's sort of de facto enforceable if individual users go to the effort of checking the integrity of the individual files they pull via hash. But we can do this in a structured protocol level way through something like Go's checksumdb, which concretely that model, given the other constraints in the Python ecosystem, is a eminently workable model. It's one that fits pretty nicely into the existing scheme of pull-down distributions. You already know their hash, or you can pull their hash, and once we have a lock file, it becomes much easier. However, it's pretty common for people to have requirements files, which are essentially lock files, but not quite, and that's a potential acceptable stopgap for that kind of scheme. Separately related to this is the issue I mentioned around release mutability. We don't want an existing release to resolve beyond a fixed set after a certain window of upload. So pick an hour, 4 hours, 20 minutes after that window. And this again, combined with some level of like baseline artifact transparency, binary transparency, reduce the incidence of surprising resolutions, as well as ways for an attacker who gains access to a project to influence pre-existing versions in a surprising way. They're forced into the open by pushing a new version, which causes more events. It changes the metadata on PyPI, for example. This has some challenges to it, but these are mostly technical, mostly around users having the existing expectation that they can upload new versions or new files to an existing release when new versions of Python come out, for example. So we want to change the impression here among the Python community that releases are in fact cheap. You can do them as often as you want. You don't have to keep the same release alive for years on end. More on the authentication, authorization, integrity side. This is another area where we think that some degree of integrity enforced via transparency is something that we're thinking about and we think would be potentially very valuable. However, this goes from left to right in terms of like where we're pretty certain to where we're less certain. And so one thing we think about here is, well, if we can make the list of ownership changes to packages publicly auditable, then people who depend on those projects can say, well, I trust requests as long as it's maintained by the current maintainers, but if something gets maintained by someone whose name I don't recognize and they joined PyPI 5 minutes ago, I probably don't want to resolve that for now. I probably want to put that on like an alert list and go triage it. This is desirable from a triage and incident response perspective, but it's also pretty thorny because, again, we're not a legal entity. PyPI is a legal entity, but it isn't a company. It doesn't have the real capacity to do things like handle PII. We try to keep the amount of of non pseudonymous identifiers on PyPI to a pretty bare minimum, and anything that involves a permanent immutable record of who owns what, which potentially includes human names, is sort of risky to us. But at the same time, it's something that we're looking at. And this is where PEP 740 comes in. So as sort of Hayden hinted at yesterday, one thing that we are doing right now is over the next, hopefully the next 2 or 3 weeks, about 18,000 packages on PyPI will begin testing overnight via their current automated CI/CD upload process. So what we're going to do is we're going to bootstrap on top of GitHub Actions, GitLab, et cetera, which use OpenID Connect. We'll use that to perform a SIG-store flow, which will then attest that the build was in fact produced on a specific machine identity. And this we're comfortable with because it's a machine identity, not a human identity. And so we're okay with having an audit log, a public, this is all going to be checked into Rekor. So we're okay with this all being public and immutable because it isn't a human identity per se and causes fewer issues. However, we would also potentially want to do it in the future for email identities, et cetera. Availability, this is even more ambiguous. So like I said, the real risk here is sort of inducing users into insecure by default behavior where PyPI becomes unreliable and they do insecure things instead. We don't really know how to do this. One thing we could do is have more explicit official CDNs. We could have relationships with CDNs other than Fastly and have fall-through mirrors where if there's an outage for whatever reason or just load is too high, you can fall through to a separate set of trusted entities who will run these, who will pay for them. PyPI itself probably won't. In theory, this could be made more trustworthy by tying in with something like artifact transparency because you can now reduce any need to trust the mirrors themselves because you can just check that the inclusion proof for anything you pull from the mirror is consistent with, or has inclusion proof and is consistent with what you would get from PyPI. But these set up time requirements too, so we're sort of just shuffling the cards here. Like we don't really know how to solve this on a more general level. And then finally, package quality. So again, the goal is to require less trust in PyPI. So it's a little bit, it's self-referential and self-defeating to have PyPI itself be the arbiter of package quality. Not only is it impossible from a curatorial perspective because there simply isn't enough time in the day, but it doesn't make any sense in terms of reducing overall trust in the index. However, again, something that we're thinking about at a high level, there's really no plans for this yet, but something that we're thinking about at a high level is the use of community reviews that are then committed to some sort of transparent log as a path forwards here. So there's been, I think, some initiatives in the Rust ecosystem around things like, I think it's Cargo, CRev, and similar tools where you can basically emit a machine-readable summary of how you reviewed a package and sign that, in which case we would do it with a machine identity or similar. And in theory, you could then store those, and then you have an auditable trail of reviews, which would remove the need for PyPI to audit these things or to review them or curate them, but at the same time be able to serve them in a way that the user doesn't have to trust PyPI to serve them honestly. However, again, this is an entire can of worms. This essentially implies a web of trust. It implies trusted reviewers. We don't want anybody to be able to spam reviews, that sort of thing. And so these are hard, unsolved problems that we could use the insights of people in this room around. So then even further into the future. So in terms of things that are currently tractable, things that we are going to do in the near future, like I said, PEP 740, we're going to do more package attestations. I pulled these numbers yesterday. As of the last 18 months, about 400,000 files have been published to PyPI used in trusted publishers. That means that when we enable package attestations over the next 18 months, we expect at least that many, if not more, attestations. And the really cool thing I like about this number is that that's only a tiny fraction of the overall number of files on PyPI, but by proportion of downloads, it's a massive proportion because the projects that have adopted trusted publishing are the most active and most widely used ones. So things like requests, cryptography, URL lib, baseline foundational pillars of the ecosystem will overnight opt into attestations. And again, I'm happy to talk about this offline because it's a pretty big scope of things, but one thing I really want to impress on this is that it's it's machine identity bound code signing without any configuration required. A user who can already publish to PyPI overnight, once they upgrade their publish action on GitHub Actions or CI or GitLab or similar, will immediately overnight begin signing with it, which was a key goal of ours, was to make it impossible for users to forget to sign or test their packages. a little bit further out is binary artifact transparency. Again, we view Go as an empirical success in this matter, and there are only marginal differences between PyPI and Go in terms of the baseline expectation that the clients have around pulling artifacts from it. So there are some standard considerations, but they're marginal in my opinion. And again, we really like this because it's zero touch and requires no real precise user configuration besides a standard lock file format, which still needs to come into existence in Python. Further into like the what might be tractable side of things. Like I said, this open-ended release problem is a pretty big one. It's technically trivial to fix. We can just forbid changes to releases after 10 minutes or something like that. But doing so will break a huge number of existing expectations around how you can publish new files to releases on PyPI. Trustworthy mirroring. Again, we're thinking about this in terms of a natural follow-on to something like attestation or binary transparency of the Go sort. But this is going to, again, require a lot of coordination and thought on who we choose to mirror with, who we want to encourage, and also if we get more major downstream users like GitHub Actions to cache, we want them to also cache things like inclusion proofs. Something that I've brought up a little bit less, but another thing that's potentially tractable is like namespacing on PyPI, and then being able to transparently monitor changes to a namespace, such as like Google changes package, some core Google package. There are both hard and soft ways to do this. Hard being like a fundamental change to the package structure. Soft being we reuse some existing part of the package prefix as a namespace identifier, and these have various technical trade-offs. There's sort of widespread consensus in the community that this is extremely desirable, but almost nobody agrees on how to do it. So it's a little bit further out in terms of tractability. But this doesn't really directly impact index trust. It's more about simplifying the package and identity tracking story, which will be important for things like attestations, where you want to say this identity should always be pinned to this package, or when it changes, I want to know. Things that aren't yet tractable. We are not going to, at any near point in the future, we are not going to remove the user's obligation to make informed installation decisions. You still need to not pip install malware. Current architectures look too much like PGP Webs of Trust, and we need sort of insight into ways to avoid those kind of bottlenecks and pain points. Another thing that isn't currently tractable, but I think will be tractable, a little bit more tractable than the previous, is turnkey log monitoring and witnessing within the Python ecosystem. So both for attestations that we talked about in the PEP 740 context, but also index-wide transparency, we want people to both monitor and witness those entries. The tools are already out there. All the moving pieces are present, but the level of effort required is currently at the level of a determined and technical user. Whereas what we want is for anybody who publishes to PyPI can then click a follow-on link to an external service that says, monitor this package identifier for me and tell me when it gets changed. That's sort of the dream. Which leaves me with my call to action. So, like I said, this was not really focused on the technical details of what we've done so far. I'm happy to talk about those. My team has mostly worked on that. It's mostly on the sort of like how we think about trust on the index side. I want this to be the opportunity where that intersection sort of collapses, where I get to talk to people in this room about how you see transparency systems reducing the amount of trust that people need to place in the index, which then allows us to divert more energy towards things that cause trust issues on the index. And finally, as sort of an observation generally, all this stuff is easy compared to actually getting into users' hands. One thing that we've observed over the years, my team helped build API tokens and two-factor for PyPI. Building those things was far, far easier than actually getting users to use them. And this we expect to be as, if not more true for transparency schemes as well. And so we could use insight into ways to, again, make this a turnkey, zero change default option for users in the ecosystem. And we could use your help with creative solutions to that. With that, thank you very much. That's my contact detail, and I think that link should work. If it doesn't, let me know.
Do you have any questions? And all right at the back. Okay.
Hi, great talk, thank you. I suppose just a question for me is so some of the decisions that have been made there kind of affect a lot of people. A lot of people have some strong opinions about them in various ways. How did you engage that community? Was it just the usual processes, or did you have to change things at all to bring in
That's
these
a
concepts?
fantastic question. Yeah, so we did engage pretty extensively with the community. So I should qualify. I am not a maintainer of PyPI. I've contributed to PyPI for about 6 years at this point. We have worked pretty much nonstop with both the PyPI maintainers, administrators, as well as the larger Python packaging and Python community via the Python discussion forum. So we tend to raise these things a few months in advance, saying, here's what we plan to do. Here's PEP 740, for example, is, for those who aren't familiar, a PEP is a Python enhancement proposal. It's essentially the Python version of an RFC. And so all of these changes have gone through public review processes with the Python ecosystem, where people have expressed concerns, and we've tried to mitigate them and reached a consensus based on that.
Peter, can I ask you to get set up as well? Yeah. We'll take another question.
Jesus. Hey, thanks. One thing that I was thinking about, when you are talking about transparency log and the users of Python, so for instance, if I'm a CLI developer, right, so I might have multiple dependencies that I rely on. Mm-hmm. Would you envision that I would be able to download all of the statements for me to republish them to my users of the API or of the CLI, or not?
Yeah, that's exactly one of the use cases we have in mind. So one of the ways that I'm happy to talk about this offline as well, but one of the things we've designed in PEP 740 is the index serves those attestations. And so the idea is that when you download things and you want to redistribute them, you can also pull those down and mirror them. Yep. Thank you.
Thank you very much, William. Okay, we have one more speaker. Okay, one more speaker. We have lunch. Will be at just after 12:30. So this is worth hearing. So just continuing with our theme. So transparency everywhere. I'm pretty excited about this next talk because a lot of the times we talk about transparency, it's in the context of digital worlds. But yeah, this is a great case where we're starting to talk about transparency, not just in digital worlds, but in the actual real world. Okay, so I'm going to hold the intro, but yeah, we'll. I think it's what. Yeah. A bit lower. Down a bit there. Yeah. This one? Yep.
Okay.
All right. We tried.
It's Control-Shift-F.
Control-Shift-F. We're going to crowdsource this. I think it is full.
Or sorry, Command-Shift-F.
Command.
Okay, I don't want to scroll the slides. Slide one, because here we are. Is that good? Cool. Okay.
Yes, okay. All right. So talking about transparency in healthcare, please welcome Peter Wells. Thank you, Peter.
Hi, just checking this works. Yes, it does. Hello, everyone. I'm Peter Wells. So I suppose just to give a little bit of context first, that a lot of the work I'm going to be talking about was done by a company called IF, and Google DeepMind Health, as was when Google DeepMind Health was a thing. I didn't actually work on the project, and I'm currently on a sabbatical, not working for anybody, so the slides will appear a little bit strange as I'm like doing it as an independent rather than as one of those organizations. So just to explain that a little bit, myself, I'm a technologist, so I'm kind of I call myself sometimes a Peter of some trades. So I do bits of technology, bits of policy, bits of design, bits of product. I work around lots of different places. So hopefully that will come through a little bit in the talk. What I want to talk about in this concept of bringing verifiable logs, using those to bring transparency to human-centered transparency to healthcare, was just talk about the problem that these organizations faced, human-centered transparency using verifiable logs, and then some takeaways from there. Now the problem, going back a few years, Google DeepMind Health was facing a backlash when it tried to launch some services in the UK, actually near here at Royal Free Hospital. Don't want to go too deep into what those challenges were, but they were trying to bring a new service that was talked about at the time, using AI or algorithms, try to help spot some kidney diseases earlier than people were spotting them, than doctors were spotting them themselves. And they were getting criticism through the media, from civil society organisations, from some healthcare professionals who didn't quite trust the service would do what it said, and then from regulators, which has meant it was hard for them to actually launch the service and get it to scale. But some people were convinced that this could actually save some lives if we were to do it well. So okay, how do we get ourselves out of this problem? And when they looked at the challenges, one of the big challenges was around data flows. So healthcare data, for anyone who's worked in healthcare, it's famously complicated, particularly in legacy systems and legacy healthcare operations, which have been around for sometimes it's centuries, and that's not just the computers that have been around for centuries, it's the institutions too. It's extremely sensitive data. People do react strongly to concerns about healthcare data, particularly primary healthcare data about individuals. The new service was making promises about how data would be used and controlled so that it wouldn't be leaking out from outside of delivering that primary healthcare service. But could those promises really be trusted? They're getting this backlash. People say, how do we trust these organisations, the Royal Free Hospital, the doctors there, Google DeepMind Health, to actually do what they're saying with the data? So that was kind of the challenge they were facing. So it started by looking at human-centered transparency. Can we bring some transparency to those data flows? And when you start to look at that, particularly in a healthcare system, there's a lot of different people involved. Actually, it's similar, I suppose, similar to actually even in software development like PyPI, there's a lot of actual different people and organizations. It's not just developers who's in the ecosystems, it's security managers, it's policymakers, it's a range of organizations developing software or consuming software. But in healthcare, you've got into patients, their families, medical professionals who've got this real concern of doing the best for their patients. They've got their professional codes to make sure they're doing that. We've got regulators, civil society organisations with different motivations. And each of those have got different concerns, needs and behaviours around this transparency and their requirements. And often it's hard for them to imagine what can be around transparency. They're used to what already exists, most people. So what was required to actually start to understand some of those concerns and behaviours was to show them design prompts to try to uncover people's needs around trust, transparency. And if we're talking about promises and promises that can be broken, when you start to get into policy world, that becomes accountability. So you have to design some prompts because people can only really limit it to what they can imagine today. You have to start to show them what could be in the future to understand what they're about. And a lot of this work was done by, I say, by IF, one of the organisations I've done a lot of work for over the last few years, including on Sixth Law, which I heard next here being mentioned in the previous talk. IF and Google DeepMind Health were interested in, could verifiable logs help? Now, this is an audience I don't need to explain verifiable logs to, but I put this slide in there for a different audience, so that when people see these slides on the internet, they can click a link and find out a little bit more. So in parallel with starting to imagine what could be in terms of artifacts and services, they were also designing a conceptual architecture. So we had product teams and designers and user researchers working closely with engineers
to say, how could we architect these flows of data? What would we require to turn those things that could be into reality? What's feasible for us to get built? And then how do we make that real? And how does this respond to what people actually need? So in this case, this is just a conceptual architecture. You know, it's showing different services at the top, going through user authentication, splitting out into multiple different hospitals. In the UK, we'd call them trusts, which can be a small group of hospitals in a geographic area. They have control over their own data flows, so they need their own data assets. They've got their own logs of who works there, what they're allowed to access and control, their own records of their patients and what patients have consented to, whether that be consent to can see a bit of healthcare information or consent to what medical treatments somebody gets. All of those things are stored as consents. And then you can wrap verifiable logs around each of those things to say who is accessing that information. You can make it very strongly tamper-proof and verifiable using those verifiable logs to start to give you, as well as that existing healthcare information, an extra set of information that could be designed into services. But it needed those teams to be working together to say, how do we design these things, how do we engineer these things, and then also how do we design them into a front end, into user-facing services. And that turned into, and this is not going to show, sadly. Let's see what happens if I do this. That got turned into, I'm going to turn the sound on here, into, so for example, this is actually a service for patients that could help them see as they take their medical treatments or finish their medical treatment, to start to explore what happened with the data about them. All underpinned by verifiable logs, surfacing the existence of verifiable logs, and starting to explain it as that was being done. And obviously I can't change back now. I might just unplug it and plug it back in again. Where is my cursor? There we go. Thank you. So that this could explain that concept of verifiable logs at what is often actually quite an emotional moment for people as a patient. And by doing that, you're starting to surface not just that the trust that this access thing has been verified, you're also surfacing ways for people to complain if they see something they don't like. So you start to open up a range of other possibilities around that. That could also be surfaced into services for, in this case, healthcare auditors, so that auditors could look at how information was being used and accessed and who by and where, to start to build confidence in that ecosystem and earn trust with what was going on. And these are all real things that were developed and deployed. And fundamentally what we're trying to turn there from was from untrusted data flows into trustworthy records backed up by verifiable logs that was surfaced to that range of stakeholders, who I suppose building on that concept of verifiable logs with monitors and auditors around that ecosystem, checking the log has not been tampered with. This starts to give you auditors around your healthcare system to check that your data flows have not been unfairly accessed and tampered with. So it just gives us, again, extending that concept just to another layer in the software stack or the service stack. I suppose, and I do talk quite fast, but some takeaways from them, going towards that concept of transparency everywhere, is this was about starting with both people and technology. So helping people imagine what could be, understanding that range of needs for the different groups of people, using those insights to help decide what to build, but by imagining what could feasibly be built, starting to work out from there. It required a multidisciplinary team. So it did require that range of skill sets to be able to bring this to life. There's a big thing there about designing verifiable logs to be understandable or explainable in some way. And that was kind of, quite a large challenge for the team. I know myself from my work on Sigstore, trying to explain how Sigstore worked to developers, let alone to other people. there's quite a lot of challenges in those things to say what's the right level of explainability to help people make better decisions, but without overloading them with information. Giving them access to more information when they want it, but without overloading them at points where they might be making sensitive decisions, particularly when it comes to healthcare. There's a bit there as well about how that broader use could help with log robustness. Unfortunately, this service in the hospitals did get turned off. I suppose I might make a joke at some point about Google's services, but that might be unfair, given the building we're in. But because in effect through this, those verifiable logs were being used by a wider range of people, that expands the community of people who've got an interest in maintaining the logs, making sure they're being monitored, making sure they're being supported. And as we all know, that can create more robustness in the log when there's more people looking at them, particularly if they've got different kind of motives and incentives and different things they're looking for to see if things have been tampered with. So that kind of broader use, embedding it in the system, starts to help with that robustness challenge. And then, again, going out to that transparency everywhere, it can help earn trust in consumer-facing services. So things like SigStore, the changes to PyPI, really, really impactful, but often they're not as visible to people. By starting to embed these things into consumer-facing services, you can have a greater trust in bringing more transparency and earning more trust, making more promises that are more provable, which can help make the internet and the software we all use every day a little bit safer for all of us. And there's just an image there, I suppose, which is a thing which has certainly caught my eye, and I imagine many others, of Apple launching their new AI services with verifiable privacy promises. Again, they're starting to see it as a consumer proposition, not just a back-end proposition in the stuff we do. So that's what I talked about. So that's the end of my talk, because I do tend to talk quite fast and try to get to the point. Apologies if that's been too fast, but I know lunch is possibly late. If you want to know more, my contact information, peterkwells@gmail.com, same on my social media platform, and the IF team are on hello at Projects by IF, again to talk through any of the product and design challenges and opportunities. Thank you very much. I hope that was fun.
That was great, and we have time for questions. You gotta come sit in the front.
Peter, great talk. One question, how were all the data flows mapped in the hospitals so that they could be fed into verifiable logs?
That's a good question. So they ended up not mapping all the flows in the hospital. They mapped the flows for this service. And I suppose they had the luxury, this was a new service. So it was a new service that was being built and deployed by DeepMind Health. It hooked into some things, like the logs of patients, the logs of professionals, but they could just say, these are the bits we do, and these are the bits we're connecting to, therefore those are the bits we can engineer.
Got it. So it was looking at making this up, GDM Health was looking at the logs written by Epic, so it was a guarantee about GDM Health use, not how all the Epic logs are used.
Yeah.
Got it.
That would have needed, for example, Epic's buy-in in that particular case.
Thanks.
Any other questions?
Thank you for the talk. Do you have any tip to explain transparency to people who are not familiar with transparency at all? And it's just like rock up to a hospital and like, oh, do you know about transparency?
I showed them the thing. So when I do it, when I do it, and I have done it quite a bit, I show them pictures of the actual services and say it's that. Often my thing for explaining verifiable logs has been, look at the padlock in your browser bar, and then from there explain what underpins that. Obviously it's gone, but so I'm going to use something else to hook off very shortly, something that people are familiar to. But I show them a service and then explain what's behind that service.
Thank you.
Okay, I'm not seeing any more hands, so thank you very much, Peter. Let's have another round of applause. Great. So this morning we had some lessons learned from CT, the most successful transparency ecosystem. And then now we've looked at different areas where we can take transparency to, from HSMs to software supply chain to healthcare. So yeah, it really is great to see, like what Al mentioned yesterday, transparency is really escaping that bubble. So we're going to break for lunch now. And lunch will be in the back of this room. We've got about an hour, and then after that, everybody gets involved, not just the speakers, but we'll be moving into our breakout session. So we'll start organizing those at 1:30, but enjoy your lunch.